Hi students, let us continue with the further part of the chapter number 2. We are doing separation techniques. Today we will be studying about is the dye in the black is the dye in black ink a single color. In the last period we had discussed about separation of camphor and salt by the sublimation process. You know what do you mean by sublimation? A sublimation is a process in which a solid changes directly from solid to the gaseous state without going into the liquid state. Today let us discuss is the dye in blue is the dye in black ink a single color? Is the dye in black ink a single color? For this, let us perform an activity 2.7. Take a thin strip of filter paper, draw a line on it using a pencil, approximately 3 centimeters above the lower edge. Put a small drop of ink, water soluble, that is, from a sketch pen or a fountain pen, at the center of the line as shown in the figure. You can see the diagram here. Let it dry. Lower the filter paper into a jar, glass, beaker, test tube containing water so that the drop of ink on the paper is just above the water level as shown in the figure 2.8 and leave it undisturbed. Watch carefully as the water rises up on the filter paper. Record your observations. So separation of dye in black ink using chromatography. The ink that we use has water as a solvent. What do you mean by solvent? A solvent is a substance which is present in a solution in more quantity. The ink that we use has water as the solvent. Solvent is a substance which is present in the solution in more quantity and the dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. Usually a dye is a mixture of two or more colors. So if a question is asked to you, what is a dye? You write the answer. A dye is a mixture of two or more colors. The colored components that is more soluble in water rises faster, and in this way the color gets separated. The process of separation of components of a mixture is known as chromatography. Chroma in Greek means color. So I'll repeat once again, what do you mean by chromatography? The process of separation of components of a mixture is known as chromatography. Chroma in Greek means color. This technique was first used for separation of colors, so this name was given. This technique was first used for separation of colors, so this name was given. Chromatography is a technique used for separation of those solutes that dissolve in the same solvent. With the advancement in technology, newer techniques of chromatography have been developed. You will study about chromatography in higher classes. Now, what are the different applications of chromatography? To separate colors in dye. Second, pigments from natural colors. And third, drugs from blood. These are the applications of chromatography. Now see, how can we separate a mixture of two miscible liquids? Previously we had seen about immiscible liquids. Miscible liquids means those liquids which mix together. For this, let us do an activity. Activity 2.8. Let us try to separate acetone and water from their mixture. Take the mixture in a distillating flask. You can see the figure 2.9 in which a distillation flask is there. Arrange the apparatus as shown in the figure 2.9. Heat the mixture slowly, keeping a close watch at the thermometer. The acetone vaporizes, condenses in the condenser and can be collected from the condenser outlet. Water is left behind in the distillation flask. Separation of two miscible liquids by distillation. This method is called distillation. It is used for separation of components of mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling point. What do you mean by decomposition? Decomposition is a process in which a substance splits up into two or more simpler substances. To separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, fractional distillation process is used. For example, the separation of different gases from air, different fractions from petroleum products, etc. The apparatus is similar to that of simple distillation, except that a fractionating column is fitted in between the distillation flask and the condenser. A simple fractionating column is a tube packed with glass beads. These beads provide surface for vapors to cool and condense repeatedly as shown in the figure 2.10. Apparatus of fractional distillation is there and fractional distillation process is shown over here. Now next is how can we obtain different gases from air? You know what is air? Air is a homogeneous mixture of different gases. Which are the gases present in air? Nitrogen is there 78%, 21% oxygen is there, and 1% other gases are there, rare gases. Carbon dioxide is there, argon, helium, and other rare gases are present. So how can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fractional distillation. So air can be separated into its components by the process of fractional distillation. The flow diagram shows the steps of process. Air is there. It is compressed and cooled by increasing the pressure and decreasing the temperature. Then it changes into liquid air. Now this liquid air is allowed to warm up slowly in fractional distillating column. After that, gases get separated at different heights. A flowchart diagram shows the process of obtaining gases from air. If we want oxygen from air, we have to separate out all the other gases present in the air. The air is compressed by increasing the pressure and it is then cooled by decreasing the temperature to get liquid air. This liquid air is allowed to warm up slowly in a fractional distillating column, where gases get separated at different heights depending upon their boiling points. Now see, how can we obtain pure copper sulfate from an impure sample? For this, let us do an activity 2.9. Take some approximately 5 grams impure sample of copper sulfate in a china dish. Dissolve it in minimum amount of water. Filter the impurities out. Evaporate water from a copper sulfate solution So as to get a saturated solution, cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulfate in the china dish. This process is called as crystallization. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Now, what is crystallization? See, if a question is asked to you, what is crystallization? You write the answer like this. What is crystallization? You write the answer like this. Crystallization is a process that separates a pure solid in the form of its crystal from a solution. Crystallization is a technique better than simple evaporation technique, as some solids decompose or some, like sugar, may get charged on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solid. What are the different applications? Purification of salt that we get from seawater, separation of crystals of alum, that is Svitkari, from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. With advancement in technology, many more methods of separation techniques have been devised. In cities, drinking water is supplied from water works. A flow diagram of a typical water work is shown. From this figure, write down the process involved to get the supply of drinking water to your home from water works and discuss it in your class. Now see, in the diagram you can see a reservoir is there. Then from the reservoir the water is being passed into the sedimentation tank. In the sedimentation tank